Alright, so this is Unit 5, Day 1. And on Unit 5 we're going to talk about exponentials and logarithms. Okay? Exponentials and logarithms can sometimes be a little bit tricky. You have been exposed to this, or you should have been exposed to this, some of it in Algebra 2. We're going to strengthen and go even further with these concepts in pre-cal. Here we go. The first one that I'm looking at is right here. I know it's a little small, but it says x to the m over n. So while the domain and range for some functions like this include all real numbers, other functions like x to the 0.5, which is x to the 1/2, are only defined for positive values of x. So to determine why, first ask, what do rational exponents mean? Now, x to the power of m over n can be written two different ways. Okay? It can be written as the nth root of x is then raised to the power of m, or you could say x to the power of m is then taken the nth root of afterwards. Either one of these is going to give you the answer that you're looking for. You may also look at it like this, with powers and properties of these exponents that we're going to talk about today. Okay, so let's look at the first one. The first one is saying PEMDAS wise, let's take the nth root of x, and then we will raise that to the power of m. To me, I think this is the one that we should all use first, because a lot of times it's easier to break numbers down to small numbers and then raise them to powers than the other way around. Okay, the other way around would be raise it to a very big number and then take the nth root of it, like the cubed root, the square root, whatever it is, the fourth root, which we're going to look at some of them today like that. These are just extensions with properties. Guys, what do you do when you have a power raised to another power? What do I do with m and 1 over n? I multiply. So if I multiply m times 1 over n, I would get my original m over n as my ratio, as my exponential ratio, my rational exponent, however you want to say it. Okay? Now, so here in these blanks, I want you to put the nth root of x raised to the power of m. Okay? And you can do it with different colors if you want. The other one is the x raised to the power of m, and then take the nth root of that. Can someone tell me why both of them work? Either one will work. This one I think is the easier one. But why do both work? Can't hear you. Same answer, but why? Why will it give you the same answer? Ooh, boy, that's 3 points right there. Because multiplication has no order, okay? 2 times 3 is the same as 3 times 2. And these rational exponents are forms of multiplication. If you have x to the power of 3, that is a form of multiplication. Do you understand? Multiplication does not have order. Now, negative exponents indicate the following. Guys, when you see something to raise to the power of a negative, understand it as that over 1. And these negative powers, you're always going to jump across, if you will. You're going to jump across your division symbol, and wherever you move it to, it changes into a positive. Do you understand? Just the power. Not the x, just the power. So, let me give you an example. What if I had 2x to the negative p? How would you write that the way that I'm saying? So this one is actually, listen, this one is actually 2 over x to the p. And the reason of that is that PEMDAS, we got to be very careful with PEMDAS. There's a multiplication here, but then there's an exponent there. So the exponent, if there's no parentheses written, grabs the one thing that is attached to it, not the entire 2x. Do you understand? So that means that would make it go downstairs, and 2 would be left up top. If I wanted to make this 2 go down with it, I would need parentheses here to make the whole thing go down. Do you understand? Parentheses with grouping. Okay, so now what we're going to do is we're going to rewrite each expression using roots or radicals, okay? And positive whole number exponents. So x to the power of 1/2. How can you write that with like radicals and stuff? Under the, say again? Under the root? Yeah, like square root of x. Yeah. Okay? This one is what? The next one. Anyone? Yep. Square root x cubed. Which one do you think this one is? Same, but with the power of 5. Now look, guys, if I told you to tell me y equals mx plus b, can you tell me what the slope of this equation is? What's the slope? It's not a trick question. What's the slope? 3. But what if I had y is equal to x plus 5? What's the slope of this equation? 1, because it's an understood 1. Guess what? We have an understood radical of 2 right here that you don't have to write it 2 there. But that's what's going on. Do you understand? Okay? Just like you didn't write this 1. You didn't write x to the 1, but it's understood. Okay? So with that, let's move on to 2. Jeremy, what would I write for the first one? Take a crack at it. X to the negative 2 with anything that we've talked about on this. How could I write that with no negative powers? Anyone? Go ahead. 1 over x squared. Okay. The next one? Anyone? 1 over x cubed. And then 1 over x to the 4th. Okay. What if I had a question that the negative was already downstairs? Then you move it up. Okay. So if the negative is up or down in the denominator, move it up, and when you do, make it to a positive. What number should be left on the bottom? An understood 1. There's a lot of understood 1s, okay? And a lot of cancellations of 1s in this unit for sure. Let's move forward. So what I want you to do is, we're going to do an example, and then there's several examples that we have for root bonus points, okay? With time limits. Let's do the first one. I have 2 over 3 all raised to the power of negative 3. The power here is 2 to the 1 and 3 to the 1. You with me? Now when I have parentheses with this exponent that's being negative, I have a choice. I could do 2 things. And here's the quote-unquote difficult part of this unit is you don't have to do it a certain way. You could do 2 different total approaches than someone next to you, but you can still get the same answer. Do you understand? Because of what Jeremy said. Multiplication doesn't have order. It's huge because some people might do it this way, and some people might have manipulated or altered it this way, but you're still going to get to the same answer if you're doing it correctly. Okay? So 2 over 3 to the negative 3 could be written as the following. You could say 1 over 2/3 raised to the positive 3. Which I think this might be a little bit weird, but you have to experience all this so that you understand which way is easier and better for you. Okay? So after this 3 would be applied to both the top and bottom. So you'd have 2 cubed and you have 3 cubed. Do you see it? So what's 2 cubed? 8. What's 3 cubed? 27. Now, what you see now looks very, very weird and foreign. Well, we've looked at some of these before. If I said, what is 1 divided by 8 over 27, and I wrote it like this, you know from recent events that you would do keep, change, flip. When you multiplied, your answer should be 27 over 8. Okay? Now watch. You can do it this way, and I'm going to leave it in the recording, of course, but order doesn't matter. You can also approach it this way. This negative 3 will be applied to everything that you see, top and bottom. That is multiplication. All these pieces have to be a multiplicative one term, okay? You can't have like x plus y all raised to the negative 3, because then it's different. So, the way that I did this one, I would immediately gravitate to these negatives and say, I can't have negative powers. In calculus all day, we can't have negative powers. We're always altering them. And the way you alter them is you move this one downstairs, making it positive. And then you move this one upstairs, making it positive. And then you simplify, and you get the same thing. Okay? Let's do B together, and then we'll start doing some stuff in groups. Please do not work ahead. Do not work ahead, because I want to give you the same amount of time on problems that you have for everyone else. What can I do first on B? Okay, so we're going to say 3 to the negative 2, 2 to the negative 2. We still have this. What would you do next? Well, we already distributed the powers. We could flip them, yeah. So we're going to say 2 to the power of 3 and 3 to the power of 2, because we did that because there were negative powers. And now, what? Yeah, go ahead.
Yeah, the exponents. The denominator 3 to the power of 2.
No. Look, guys. This was a negative 2, right? So 3 to the negative 2 moves downstairs.
But that's 2 to a negative 3, and it should be a 2 to a negative 2.
Oh, nice. Okay, so this right here should be a negative 2. I don't know why I put that. But thanks for that catch. So that this would be a positive 2. Nicely done. Thank you.
Yes.
So 2 to the 2 squared over 3 squared times 9/16. What would we do? What would I want you to do next? Okay, so yeah, you'll see the same thing, exponents, multiplication. You see right here, what number do y'all see right now? 4. What do you see here? 9. So what would you think I'd want you to do right now? Simplify and cancel. Please do not multiply and get 36 over 9 times what? You know what I mean? What are you doing? Let's reduce and simplify our life as early as we can. So this 9 and 9 will reduce to 1 and 1. This 4 and 16 will reduce to 1 and 4. And our leftover pieces, then when we multiply straight across, are a lot easier to quickly get to 1/4. Cool? Alright, so now what I want to do is I want you to do C in groups, 3 minutes, have the final answer, and then we'll go over it really quickly. So there's the explanation as far as how we reduce this to 1/2. What I want you to do now is you're going to do 2 problems after the one we do together. And you're going to do it in like 5 minutes. And again, for 2 problems, don't start early. Please don't work ahead. For 2 problems, we're trying to see what's the most simplified form. You can't use your calculator. You can't use the Chromebook. Nothing. It's all by hand, okay? Let's do 4A together. 4A. Are these the same, yes or no? Is that equivalent to what I wrote? Is that equivalent to 4A? Yeah, so we can do this. Now from this, Some of you might actually multiply 7 and 28. And that's a lot of work. The goal is to teach you number sense factoring. When I look at 28, and I'm looking, and look, this tells me to factor. In some regard, this is telling me I need to factor these pieces. What two numbers pop out when you look at 28? 4 and 7. So if 4 and 7 pop out, okay, and you still have this 7 that you haven't touched, can you see right now that the square root of 49 will come out? Yes or no? What does it come out as? 7. What does a 4 come out as? 2. A 2. So what do you do when they come out? You multiply them. And only 1's left inside. There's the square root of 1 is 1. So the answer that you should get is what? No? 14. My bad. So 14, because you're multiplying them. Okay? Are we good?
How did you get the 1?
Because an understood 1 is always in there.
Okay, so how did we get rid of 4?
Yeah, so we got rid of the 4. The square root of 4 came out as 2.
Oh, okay.
And the square root of 49 came out as. And the reason why I'm showing like this, some of you are like, why didn't you just write 49? Why did you write this nonsense of 7s? Because here's the thing. I'm asking you for the square root. What if I were to ask you for the 4th root? See, you would need 4 different 7s before you brought them out just as 1 7. You with me? Okay? Which is what you're about to experience in some regard here in just a bit with the next 2 problems. I'll pause the video. You work for 5 minutes and I'll show the answers afterwards. Go for it. Alright, resuming. We are looking at 48 over root 3. Now look, again, I'll remind you, the difficult part, as some of you are saying it, is you're not understanding the number sense and the approach of the number sense. What number is understood to be there? That it's not written? 2. So I'm looking for pairs of numbers, okay? So 48 and root 3, I'm going to start breaking them up. And you can do 2, okay? You could do 2 and what? 20 what? 24. You could do 2 and 12. You could do 2 and 6. And then you could do 2 and 3. Y'all with me? So that you have all of these, and a lot of you are like, ugh, but this is the number sense behind it, okay? You have, how many 2's do you see? 4. Now you could write them out, those of you who are really, really big on visual learning. If I'm taking the 4th root, they would all come out as 2. Do you understand? But because I'm just taking the square root, that means I'm going to group them in pairs. These will come out as 2. These will come out as 2. So the answer out here is just 4. Because you multiply as you bring them out. And some of you might look at that and be like, it's just 16. Take the square root of 16. But you're missing the number sense part. Okay? Alright. So all these came out as 4. And root 3 was still left in there. You with me? Can you break up 3? No. But if you have root 3 over root 3, you can cancel to a form of 1, and your answer would be 4. Now listen, that's not the only way I need you to learn, because the number sense will build, I promise, but you almost have to force yourself to use it. And it sounds and looks difficult at first, but I promise you it's not, and it strengthens you so much more if you practice other manipulations. Especially if you want to take calc with me next year, okay? You have to see it many different ways. Yes?
Can you just bring out 12 and 4?
You can. Let me show you something real quick though, okay? From a property that we just learned. This is the same as that. Okay? What's 48 divided by 3? 16. So now just take it out, you get 4. There's more than one way to do this. You need to understand all these, because some are easier. Okay, here we go. Let's now go to this one. We're taking the 4th root of 24 and the 4th root of 54. This one's a little bit lengthier. 12, here we go. 2, 4, 8, You see what I'm doing? 16, but then it's weird after that, right? You're not going to get to this 24. So the best approach is to quickly try to break these down to like 6 and 4. Let's break down 54 to like 6 and 9. You with me? And we're going to take the fourth root of stuff here in just a bit. Okay. Now, could I combine these in one huge fourth root that includes all four of these? Yes or no?
Yes.
Yes, because it's one of the properties that we learned with square roots. Okay? And they're only positive square roots. We can't do this with negatives because those are i's. So if I break down these, I'll have 2 times 3, 2 times 2, 2 times 3, and 3 times 3. And I'm going to take the fourth root. That means as soon as I find 4 of these guys, they're all going to come out as what?
2.
As 2. So now you have 2, the fourth root of all those 3's. How many 3's do we have? 4. So they're going to come out, right? As what? As 3, which you would then multiply to get 6. Okay? Let me pause the video real quick so I can get a tally. Okay, my bad. We're going to, wait, hold up. We'll do 5 and 6 together. Then we'll do 7, 8, 9, and 10 as bonus. Okay? Here we go. Watch.
We do 10.
Shh. 6 to the 4. Y to the 12. Right? And then you have 2y to the 5th. Now watch. 6 to the 4 is a huge number. So it's like 6 times 6 times 6 times 6. And then you have 2, and then you have the y's competing with each other. Who wins with the y's? The top. And the reason why is because when you're dividing, you end up subtracting the powers. When the bases are the same, they have to be the same, you're going to subtract the powers. This will help you. So those of you who are trying to go for perfect on those last 4, pay close attention to this, okay? This doesn't get rid of the base. It just says that it's going to be y to the 7th. And you can look at this and say, who wins? The top. The top by how much? 7. So you'll say y to the 7th should be on top. Now let's say this. What if this was y to the 5th minus y to the 7th? So it looked like this. Y to the 5th over y to the 7th. You with me? That means you subtract. What would you get here?
Y negative 2.
Y to the negative 2. Which if you rewrote it and simplified, would say that the bottom is this, which shows here the bottom 1 by 2. That'll help you on the ones that you're going to do here in just a bit. Let's practice these together though. Y1 up top by 7. 2 reduces with one of these 6's, making it into 3. You understand? So now I have y to the 7th. 6 times 6 times 6 is 36 times 6. You with me? So you get 18, 19, 20, 216 times 3 is 18. Carry the 1. 648 y to the 7th will be the answer reduced. Do you understand? No, this is all by hand. Okay? Now watch. Shh. Let's do one more and then ask me questions if you have them, okay, before we do the bonus questions together with our groups. This 2 is a power of this parentheses. So that means it's going to apply to this and this, so that it's 2 squared. X to the what? Anyone? 6. Good. Then it's times 3 times x to the 4th. And what's on the bottom? X to the 12th. Nice. Because a power raised to a power, you multiply. And you said it yourself. If there's just parentheses in between them, that's a good way to remember to just multiply. Okay? So the hard part is remembering when to add. And that's when they look like this. This will add to 10. These are just made up problems, will multiply to 16. This parenthesis said to multiply. this multiplication with the same base. You see this second base is there? There's not an x over here. But this second x here says I'm going to end up adding those powers. Okay? Alright, let's go. So now we just have to simplify what we have. How many x's do you have in the numerator? 10. How many in the denominator? 12. Who won? The bottom by 2. And then now what do you have left over simplified up top? 12. Because you have 4 times 3. And that would be your final answer. Final answers cannot be written with negative powers. Do you understand? Okay. Now you have 10 minutes with your groups. Go for it. Resuming the video, we are going with number 7. This 3 applies to everything to change it to 2 cubed, u to the 6th, and v to the 9th. Powers raised to a power, you multiply. Notice I didn't multiply 2 and 3. That's a common mistake. People will put 6 here rather than 2 to the 3. Because what you're really multiplying is this understood 1 with 3. Okay? Next, the negative 2 will distribute to 3 to the negative 2, u to the negative 6, and v to the negative 2. Negatives move, right? So all this is over 1. So that these negatives will move downstairs to be a positive, like the following. That gets rid of all of this, because it just moved because of those negative powers. Who won with u? They tied, so they canceled to 1. Who won with b's? The top, by how much? 7. Now I have 2 cubed, which is 8, over 3 squared, which is 9. There's your most reduced form. Let's keep going. This one is 4. X to the 4, y to the 8th, because you multiplied, z to the 12th. Then you have x to the 9th, y to the 6th, and z to the 3rd. Now let's think about x's. Who won? The bottom by 5. Who won with y? The top by 2. Who won with z? The top by 9. That is your most reduced form. Okay? Let's keep going. 2 more. These are the ones that are left are 3a squared or ab squared c over 1 times, now watch, I'm going to apply 2 to all of these, a negative 2. And then I'm going to flip them. So when that happens, I'll get c to the positive 6. Okay? And then I'll get 2 to the squared, a to the 4th, and b squared. Look at this. B's cancel. C's become 7, and AY's the bottom one by 3. So now I have 3 over 4, and this would be the most reduced form. Last and not least, we have the following. 2 to the 3rd, x to the 12th, y to the negative 12 over 5. Then we have 8 to the 2/3. Oops, what am I doing? 8 to the 2/3 is in the numerator, not the denominator. And then we have y to the 4/3. Okay? The only one that's going to move is this negative power. And when it moves, it will become y to the 12/5 on bottom. Look at this. The cube root, look up here please. The cube root of 8 will become 2. Squaring it, this becomes 4. This over here, 2 cubed is 8. So the top, I have 32. X squared. And now we just have to figure out who won. The 12/5 or the 4/3. Do you understand? So you could say 4/3 minus 12/5, with which common denominators, watch very carefully, is multiply the first by a form of 1, 5 over 5. And a 3 over 3, which is a form of 1. So you get negative 16 over 15. That negative says it will be downstairs as this.